We're going to talk now about projections. So different ways in which we can flatten the surface of the Earth. They are called projections because they pretty much use the same thought that we would have when we have a film, a lamp, and then the images in the film are projected to a screen. In this case, the film is going to be the surface of the Earth. We're going to put a lamp, in many cases, in the center of the Earth so that we can project the surface of the Earth that is going to be assumed as a film. And then we're going to put a screen. For example, for the conic projection, we put a light bulb in the center of the Earth. The surface of the Earth is going to be the film that is going to be projected on a screen that is going to be the cone that you can see there. Now, the shape of that cone is going to depend on the parallel of tangency. And if the angle of the cone at the highest point up here, if the angle of the cone is large, I mean, close to 180 or which number, then the parallel of tangency is going to be close to the North Pole. If that angle is very small, the parallel of tangency is going to be close to the equator. So the geometry of that cone is going to change depending on the angle of the cone, or another way of saying the same thing would be depending on what is the parallel of tangency. Once we project everything on the cone, we cut the cone and then lay it flat, and that is going to be our flat map. In the case of cylindrical projections, we put a cylinder around the Earth, turn the lamp that is on, which is at the center of the Earth, project everything, and then just cut the cylinder at a certain, let's say, vertical, and expand it, and that is going to be the projection of the Earth. You can also have what is called azimuthal projections. And those projections are usually used for the North Pole and South Pole, but we're not going to spend too much time talking about azimuthal projections. Most of the projections that we use are going to be conic and cylindrical. So we have conic, cylindrical, and azimuthal projections. That's pretty much what we've been talking about. This is an example of a conic projection. In order to decrease distortion, instead of having the cone tangent to the surface of the Earth, it's better to have it secant. So by doing that, we're going to have two what is called standard parallels, which is where the cone intersects the surface of the Earth. All the area that is within the standard parallels and a certain distance north of the northern standard parallel and a little bit south of the southern standard parallel, all that area is going to be projected with a relatively high accuracy. As you depart from the standard parallels, north and south, as you depart from them, you're going to have more distortion. So as opposed to what I was saying before, having two standard parallels instead of just one is going to decrease distortion. Once you have projected the surface of the Earth, you take your cone out, you define what would be your central meridian. The central meridian is usually what you would like to be the center of your map. Then you cut it exactly on the other side of the cone, you expand it flat, and that is going to be your map. So if you want a map of Texas, for example, most likely you would like your central meridian, this line here in the cone, it was this line here. You want your central meridian to run through the area that you are interested in. These are conic projections. You can also have cylindrical projections. When the cylinder is oriented like this figure on the left-hand side, that is called normal. If it is oriented like the figure in the center, that is going to be called transverse. And if it's inclined, it's going to be called oblique. But I've never seen one of those projections. There are many projections that are transverse projections. And these projections are going to have this meridian of tangency. So that means that the projection is going to be perfect along the meridian of tangency and a little bit to each side. But as you depart from this meridian of tangency, the distortion is going to increase more and more. Azimuthal, you can put your plane wherever you want, but as I said before, I've seen azimuthal projections to be used only for the North Pole and South Pole. These are examples of projections. This is an Albers equal area conic projection. So it comes from a cone, and it's an equal area. That means that all the areas, the areas are preserved. For example, all these orange ellipses that you can see on this map, all these orange shapes were circles on the surface of the Earth. They were all circles, and they were all the same size. Now, in this specific map, they are not circles anymore. There are a few that are, but the others have been distorted. In general, they are not circles, but they are all the same area. So this projection is a projection that preserves the area, not the shapes. If you care about the shapes, this is not a good projection. But if you care about the areas, this is good for preserving areas. Another projection is going to be this Lambert conformal conic. It's a conic projection. Conformal means that it preserves shapes. Again, all the orange circles were circles of the same size on the surface of the Earth. When you create your map, they are still circles because this is a conformal projection, but they are not the same size. Some areas look much bigger than others. You can see South America is much bigger than what it really is compared to North America. So everything that is in the southern hemisphere in this map is larger than what you would have with other projections. So Australia, Africa, South America, in this specific projection, they look larger than what they really are. But this specific projection is not concerned about preserving areas. It's concerned about preserving shapes, and it is preserving shapes. These are examples of mapping the United States with 3 different projections. As the area becomes smaller and smaller, the maps look pretty much similar. If you put one on top of the other, you're going to notice the differences, but that is how meridians and parallels look like. You can see in this Albers equal area, the North Pole is this line, is an arch. In this Lambert conformal conic, the North Pole is going to be a point. In this universal transverse Mercator, the projection is going to be, the North Pole is going to be a single point. So that would be about the different types of projections.